This is stream number 12, making my own keyboard. And if you were here for the last 11 streams, you might notice a slight difference. I actually now have a real keyboard. So the boards came back. At the end of the last stream, I had just finished the design for one half of it, so didn't have time to stream it, but it was basically just copy paste and flipping it around to make the other side, and then I sent off the files to Board House to have it built. And it came back while I was at TwitchCon. So when I came back, I'd also had ordered parts. So I got the PCBs and the parts, and again, can't stream from where I soldered the stuff together, but got it all assembled, and I'm like, great. Now on the next stream, I can actually show you guys the first prototype. So here it is. And almost everything went well. There are a few errors on this board. And to give you a hint, let me open up the data sheet for something and then show you what my layout looks like. So what I'm going to bring up here is the data sheet for the NeoPixel. And maybe you can kind of guess what I did wrong here. Maybe not. But let me scroll down to where I show where it has the pinout on this thing. Where is that? Right here. So notice how where this cutoff triangle is, both on the face of the NeoPixel and here on the pad, that's ground, pin 3. And this is the emitter side, so this is what direction you'd face if you want to see the light, right? And this is the back. Okay. Now, keeping that in mind, let me show you the PCB. Illustrate the error I made. So I had this left-hand side, I think, at the end of the last stream. I basically just copy-pasted it and relayed it out on the right off-stream. And I added these little breakaway tabs, which is how I got it to print as one solid board. And then you kind of break it in half and you have your left and your right, right? Okay, so these NeoPixels here are on the back side. So if I go and flip the board view around, now we're like looking at the back of the board, right? Now, do you see the problem here? I didn't. Alt-tab, right? So, remember how I said that if ground is in the bottom right, this is the side we would see the light emit from? Well, here's the ground. That means that the light is going down instead of up. So, instead of these being per key LEDs, they're actually not shining in the right direction. They're shining down, more like an underglow LED. So basically I had these backwards. And so when I realized that while I was soldering the parts to it, I'm like, well, I was bound to make some mistake. So that's okay. For the next board, we'll fix it. I totally expected to make some mistakes on this board. I was actually surprised with how few mistakes I actually found. All the NeoPixels being upside down was one mistake. I think the only other one, let me think about this, might be that these breakaway tabs are, there's a little bit too much material, because it's actually kind of hard to break them off from each other, but that might be okay. Also, it's sort of a bland, boring square, as you can see right here. But I mean, the good news is both the audio jack and the USB work, and I was actually able to solder these through hole pins right here, even though they're super close together. I didn't even have flux, but I still managed to get it working. It's a pretty awful job, but it managed to do it without any shorts. And as you can see, it's actually operational. So I did a little bit of editing to the code just to test things out. Essentially what I did is I added the 2 extra rows here. I didn't have them before. So there's a row 1 and a row 2, and I changed the scan codes. So that's further down. I'm using scan codes 30 through 35, so that maps to the 1 through 6 digits. So if I go open, that's not what I want. There's what I want. If I open a terminal here, so I get 1, 2, 3, 4, 5, and 6. So the right-hand keyboard doesn't do anything yet on the host because I haven't yet written the code to forward the key presses from the secondary board back to the host. I haven't written that code yet. But otherwise, like, everything works as before. So here on the monitor, if I hit, hold down keys, they come back directly in the keyboard report. If I hold down keys on the secondary board, it's generating a report that's just not being used, but the log information for it is being forwarded from the secondary board. And this works whether I use the audio cable or the USB cable, which is really nice. I can kind of compare and contrast the two. I don't have a really nice TRS cable for this yet. I have that ordered today, a nice braided cable. So this one's kind of stiff, so it's not ideal, but it's fine for testing. Hey there, VR Lucas, how are you today? All right. So what I wanted to do today is, even though the NeoPixel LEDs are on backwards, let's turn this around. Even though these two are backwards and they won't shine through the keys, I should at least be able to light them up, and then we'll see if I have this upside down. We should at least see it emitting up to the camera, right? So that's my objective today, is to actually illuminate those LEDs just to verify the circuit is correct. And if I'm through with that and I still want to do some more streaming today, the next thing I want to do is relay keyboard reports from this board over to the host. Because like I just showed right now, I can press keys on the left-hand side and they turn into actual key presses. But if I do that on the right-hand side, they're not actually causing key presses because I don't have the code yet for that. You're glad the series is landing and YouTube wanted to watch them from the start but couldn't find the VODs? Yeah, they're in YouTube. I have to upload 3 more and release them. So I think YouTube's 3 VODs behind. So if you missed that, you missed me constructing the circuit board for this. That's about it. That took like 2 or 3 streams, I think. Okay, I'm gonna leave this turned upside down here and work on the code for that. So just because it's easiest, I'm gonna look back at my not the board layout, but the schematic, just to remind myself which GPIO was tied to those NeoPixels. So it was GPIO 18. So I just need to enable another NeoPixel on GPIO 18. Don't want spoilers, so you're gonna watch the YouTube series? That's fine. You probably already have the link, but any lurkers out there who also want to see it, there's the link to my where I upload things to YouTube. So I'm making a playlist out of the VODs of this series. Okay, so there's this existing NeoPixel here. That's the onboard one that we see there blinking. So these two are essentially the same chip as on here, or at least the same API. So I think I can construct it the same way, only using a different GPIO. So let's see if I can do that. So let's say this is switch 1, or this is the switch LEDs. All right, see ya. VR Lucas. Let's say the switch LEDs, and these are daisy chains. So we basically make one object and we write a sequence of colors to send it all down the daisy chain, right? So I think here we have to pick a different state machine, separate from the one we're using for the onboard NeoPixel. That's my guess. And instead of using the NeoPixel pin, we're going to use GPIO 18. Unless it's named something different, which it probably is. Yeah, so it's named S clock, but I'm not using it for serial clock. I'm repurposing it to use as GPIO 18. Okay, we need this state machine, right? It's probably given to us by this split. Yeah, so it's that second argument. So I would put it here, SM1. Okay, so with that switch LEDs, I think I can use it the way I was using the normal NeoPixel. So let me find where I do that. Okay. Probably this one? Here we go. So it's like this, right? So let's just put out some colors. So we'll do switch LEDs dot right. And here, instead of using once, we actually need to make an iterator with which generates two things, right? So what's color gonna be? I should have copied a color, right? Yeah, like one of these. Okay, so we'll just fill one in. And then I think the easiest thing to do would just be to do a, was it join? Or chain, right? Chain with another once. With another color. And this needs to be mutable. Okay, so let's pick some colors. How about red and green? Just to keep it easy. So the idea is we have a daisy chain. So the first color would end up going to the second switch because they're written serially. So it first writes the red value out to the first switch, and then it writes the green one to the first switch, and then the red one gets forwarded. So I expect this one to end up green and this one to end up red if I remember the ordering of these correctly. So let's see if this works. So build. I have to actually spell the word build correctly for it to actually work. All right, and then in my other window, I can just say program. Where are you, other window? Here you are. So put the cursor in there, hit Control C, and then program. So it's programming both boards. Now it's reprogramming. Oh, check it out. Works first try. So the first one got red and the second one got green. Is that what I told it to do? Okay, I actually thought this one would be green and that one would be red. So I wonder if that's because this right actually reverses it. So there's no documentation for that function. Oh, I think I have to actually go to where that's implemented, right? Oh, that's not documented here either. Is it the driver here? No, it's the same one. Wait, the driver implements smart LEDs right also? Oh, it's a direct. Okay. Okay, here we go. Is that where I was? No. Interesting. Oh, that's this line. Okay, never mind. You have to wait at least 60 microseconds between calls to this function. Either use a timer or use WS2812. So it's not reversing the iterator. Okay, writing out red first and then green. I expected the red would indeed appear here, but then it would move, we would shift down to here when we write out the green one. But it didn't. This is the first switch. Somehow this must reverse the iterator. Okay, well, that's good to know that we need to write it in switch order. Cool. Okay. And so this probably did it on both boards because I programmed both, right? I turn this over. Yep, I can see the reflection. See the reflection right there on the desk? So it also wrote out red to the first one and green to the second one. Cool. All right, well, that was easy. I don't know what to write on to the switch LEDs yet. I guess in the future what I'd do is I would write out whatever colors correspond to the algorithm that it picks. So like one algorithm might be each time you tap a key it would light up a color, and then the color would change over time or depend on how many times you hit the key or something like that. So rather than just hard code this, I think what I want to do is just take the switch LEDs and then take them and stash them into the self object, right? So I'll just remove this, or maybe just keep it around as an example. This is how we write out the state for all the LEDs. Actually, I want to do a little experiment where I only write one color and see what it actually does. These in the chain. I want to say all the elements in the chain of key LEDs. Key LEDs? What I want to do actually is make a copy of this. Take the original, comment it out. And on the copy, I want to just write one color. To clear them all, I would have to write a chain of zeros, right? Otherwise, I'd have to power the board off and then on. I guess I can do that really quick. So what happens if I just write one color and not write a second one? I want to see what happens if we do that. Because I thought it would make, I should just show it. I thought it would end up making this one red because that's the first color we wrote out and it would shift them out, but it turned out to be backwards somehow. So what if we only write one? Does that mean this will be red and this will be off, or this one will be off and that one will be red? Let me see what happens. So, build. So I think the easiest way to make them dark is just unplug it and... Oh, actually when I plug it back in, it's going to reprogram them. I really should program and then unplug and replug them, right? So Control C and reprogram. Okay, and then let me take power off and plug it back in. Okay, so this one stays dark and that one goes to red. So I think it must reverse the iterator and then send them out in a sequence. It doesn't know how long the daisy chain is after all, right? Okay. Then I understand, I guess, how this works, and we'll just put this in the comment here. We specify the LED colors in order. Beginning with the first in the chain. I didn't want it to end. Okay, hit hard enter there, and then I can wrap this with the first in the chain. All right, I'm gonna leave that code in there, and well, we'll keep this, but we're gonna stash that switch LEDs in the self object to be used later. We just need to get the type of that. It's going to be kind of like the type for this NeoPixel, right? Switch LEDs. Only this will be PIO1, I think? An SM1? And GPIO 18, right? Yes. Okay, and then the type magic should make sure everything matches. I just need to import all these symbols. And it's not right, so what's different here? Is using PIO 0? Really? Oh. Do we have more than one PIO? I guess we'd have two of them. So I'm using a different state machine of the same programmable I/O block. Okay. Then this is PIO 0 after all. But state machine 1 of programmable I/O block 0. Okay. Then we don't need PIO 1. And to get rid of this warning, I think I need to mark that just we're not using it right now. I could put an underscore in front to say that we're not using it, right? Okay, so then for now it's unused, but we're still constructing it. Let's make it consistent here. Hey there, Tuzzle, and hey there, Stripe Monkey. Isn't that once new for the green being evaluated first? I thought that that would be the case, but I'm assuming then, since it's not, because it does have to be pushed out like a shift register, that it must be internally reversing this iteration and pushing the green out first and then the red, in order for the red to end up in the first in the chain and green to be at the end, or the second. So yeah, it looks like it's going to first shift in red and then shift in green, so I'd expect this one to be green, this one to be red, but it was flipped. So I'm thinking this write function must internally reverse that iteration. Plugging sound really gets you when you hear it? Oh yeah. Maybe I should just turn off the plug-in sound. Or actually, better yet, I could just make it local so that only I hear it, right? That's probably a better idea. I'd have to muck with the default sound output in Windows to go to my off-stream channel in Voice Meter. Okay, make sure this builds. Okay. Program, and then when I reset power on this thing, it should not light either one up. But we'll have the capability of lighting them up later. I'm really happy that the wiring worked on both these boards. For at least those two LEDs. I didn't bother to populate the other 4 LEDs because these are backwards anyway. It's like, why waste those LEDs? On the next rev of the board, we'll have it flipped. In fact, I should probably fix this PCB right now, right? Okay, let me verify that if I pull power from it and I put power back in, it's not lighting them up anymore. All right. Let's check this in. Okay, so we added GPIO 18, state machine 1. So we could set up the switch LEDs, and then I have some commented out example how to light them up. Okay. Stage that in Git, commit it, and we'll say that set up resource for controlling key LEDs. Push that. It's great, you just didn't expect it? Yeah. I forgot the command in chat for that. It explains it. Maybe it's bada. There we go. It's the USB attach notify sound. Because I find it a little bit disconcerting when I'm watching someone else's stream and their USB sound goes off. I'm like, what happened to my USB just now? And it's not me, it's them. That's why for you guys I picked a different sound, so you know it's my computer, not yours. All right, so I'm gonna turn this back over. We'll table the work on the LEDs in software for now, but let's go back to the PCB and fix the mistake there. So again, the mistake was these are backwards. So we're looking at the back of the board, and we're seeing the ground is in the bottom right, which is a problem because the ground is only on the bottom right when the LED light is facing you. So we actually want to mount it on the board this way, which means ground is flipped over from right to left. So ground should be on the left, D out should be on the right. Right now, D out is on the left and ground is on the right. Similarly, power should be on the right and data in should be on the left. Right now, power is on the left. So I need to flip these all around. And I suppose where I want to make this fix is in the symbol itself, right? Oh, the other problem I had, it's kind of hard to show this without like bringing it close to the camera, but the pads for the, I can show it here, the pads are pretty small. So I kind of want to make the pads bigger so that I have more surface to work with when I'm soldering it. And we can afford to make it a little bit bigger without colliding with the adjacent pad, right? So I want to fix that at the same time. So that would be in the footprint editor. We could probably see the problem if I look at the 3D model in the footprint editor too. All right, let's find it. Under project, there's NeoPixel, right? Yeah, so pin 3 being ground, right? This only makes sense if we want the light to shine up. But normally when we mount these, we want it to show down. So do I fix the footprint, assuming that you want, because the footprint includes this cutout. Actually, that's another problem. I might want to have two footprints, one for NeoPixel facing through the board. So, like, because this is a reverse mounted part, right? So this would be the normal configuration would have a cutout here. This edge cut. It would have that edge cut, and then we would actually want to mount it reversed. But you could also mount this the other way to have it be an underglow LED. Then you wouldn't want the cutout. So yeah, I think the right thing to do here would be have a copy of this footprint, one for reverse mount shine through board, and the other one for underglow, basically. Hey there, Grey Jack. Okay, so probably more people are watching, and I can go over again the essential point here that I got my board back from the board house, and I soldered parts on and realized pretty quickly that I mounted the LEDs backwards. And if I show you the again this pinout, ground being bottom right, if the light is facing you, problem is on the PCB I had mounted on the back in the same configuration as the light facing you, which means it's facing down instead of up. It's not shining through the board, it's shining away. So let me start by making a copy of this footprint. Or just do copy paste. Yeah, and in the copy, can I just rename it by clicking here a couple times? Can I rename here? Do I want to do save copy as? Or do I want to do footprint properties and change it here? Ah, yeah, footprint name. So we'll call this NeoPixel reverse mount. Shine through board. Okay. And on this, save that one. On this one, I'll call it shine away from board. Okay, and then save that. Okay, so for the shine away from board, actually I just realized something. I should have fixed the pads before I copied it. Now I have to do it twice. For the shine away from board, we don't want the cutout at all. So I'm going to select the cutout and delete it. How come it won't let me select the cutout? There we go. And then just delete it. Yeah, okay, so we'll fix the pad size now. Why did it have these particular dimensions? Is that from the datasheet? Is that here in the datasheet? See, it had a different dimension. Maybe I just messed up and didn't type that in. NASA makes mistakes all the time. Well, I knew I'd make some mistakes. That's why I only made a 2x3x2 keyboard. Right, it can't function for more than like a number pad. It's not the final product, because I'd rather make mistakes on the small 2x3 boards than on the final product. But okay, where did I get these dimensions? 0.97 and 0.82. That'd be like... I mean, that isn't even really the dimension of the... Oh wait, I know why. Because we couldn't put solder paste so close to the edge cut. So I intentionally did that on purpose. Okay, so then the real problem is, I think I used this dimension instead of this one. It's 1.8. Instead of 1.8, I use 1.34. So let's measure that. If it's 1.34, then that's the problem. That's why the pad isn't as big as it should be. Measurement tool. Well, it's certainly not 1.8. Why is it 1.5? That isn't even the correct dimension at all. Huh. Hold on, let me go take a NeoPixel out of the bag and actually look. Well, I can do that later. Let's just assume that I got it wrong completely, and we'll just fix it to match what this shows. So if I want for the PCB to have it go out 1.8 from the board, where would that be? That would be out to here. It would go out to there, right? So where is there? Negative 3.45. Okay. Out to there. That's how far it should go out. And probably the same thing on this right side. So where's there? That's out to 3.5. Out to there. Okay. Is it just a hobby project or a work commercial? This is a hobby project. If you would like to read more about it, here's the link. Yeah, everything I do on Twitch these days is a hobby project. Okay, vertical dimension 0.82. I don't think that was correct either, right? Okay, no, that dimension was correct. I just had the pad size X wrong. Okay, so that's a better dimension for it. So we'll just hit save on this guy. I need to do the same thing on the copy of it. Let's see if I remember. It was like negative 3.45, right? And on the right side, it went out to 3.5. There we go. Okay. But when it's reverse mounted shining through the board, we have to flip these pads around. Or alternatively, I can say it's back copper instead of front copper. Probably makes more sense though to flip the pads around, right? So let's flip them around by just taking the 2 away for a second. And we'll take the 3, rotate it, and place it there. Place the 2 over here. Hopefully I got... Hold on, let's get the vertical position the same, 0.755. 0.755. Okay. And the same thing here, right? Move pad 4 over to here. And pad 1 over to here. Okay, what's the vertical of this? Negative 7.5? Negative 7.5, right? Okay. So I basically flipped the part upside down so it's facing the correct direction if we wanted it to shine through the board. Let's hit save on that guy. Okay. Then I want to go to the schematic. And if I remember right, there is a way to look at all of the footprints here. Assign footprints, right? It should give me a table. Beep, beep. There it is. So I want to make sure that these are all picking the correct footprint. Right, so then I'm going to go to Project and pick Reverse Mount. And then apply, save schematic, and continue, right? All right, and then we want to go over to the PCB and update from schematic. There we go. So the pads moved and now the connections are wrong. Flip pad 3 along the x-axis so the pad corners on the outside. Oh, did I forget to do that? Oh, right, I flipped it the wrong way. You're right. Thank you, Stripe Monkey. I rotated it instead of flipping it. That's my bad. Let's fix it. All right, this guy, rotate him back and then I flip it, right? Mirror. That didn't do anything. Just say bottom right instead of left. Is it because I have it rotated? Yeah. How about I just say bottom left? That should match the data sheet now. Yeah. By the way, do you see the bug here? If we believe this, and I do believe this because that's what I tested, the ground is the one with the triangle bite out of it, right? But on this page, they actually flipped that over to the left, but they didn't move the pin numbers or labels. So I have to be careful when I look at this to know that these labels are wrong. This is, actually, there's also a triangle here. So really, it's the pad that's wrong. It should be this one with the triangle cut over here. Anyway. It would look like that. So that is correct, right? So let's save that. Cool. Then back to here. Actually, no, I want to go here and go to assign footprints again, right? This is probably the easiest way to do it. Hey there, Everex. How are you doing? Put a comment in the PDF since you can. Also, good morning, good evening. Yes. Good morning, good evening. There's probably an easier way to do this, but I'm just going to go do what I just did and just like reapply it. And then click here and then click here and do update, and it should have no, it didn't fix it. Do I have to like refresh? Hold on, assign footprint, right? Do I need to like press a button to update from library? Let's see. This is filter. Delete. What if I right click? No. What happens if I do view selected footprint? Will it look correct? So that looks correct. So the footprint is assigned, it just didn't update it. So there's like an update button here, right? This alone didn't do it. So what was that button? Was it that I have to pick it here and say update? Okay, yeah, update symbol from library, but oh right, update symbols matching library identifier. Update the footprint. Update. Cool. It updated all 12 of them. Close. And then might as well hit save here. Update from schematic. Update. What errors do I have? Oh, hold on. Did I get that wrong then? Is this footprint wrong now? Oh yeah, I gotta reselect the footprint. I didn't have to do that before. Do I have to do that for all of them? I guess so. Can I just shift select all of them? Can I edit them all together? E didn't seem to do what I hoped it would do. Okay, I guess I'll just do them all. I mean, it's not that, it doesn't take that long. We only have 12 of them. Because I changed the name, I guess it broke this reference to the footprint. We all want them to be reverse mounted shine through board. Okay, that's half of them. There's a replace functionality somewhere? Yeah, but I'm too lazy to do it. Sunken cost fallacy. It's like, I'm almost done. I should just do it the inefficient way for the rest of them because I'm almost done. Yeah, almost done. Maybe next time. One more. Okay, so save that. Click here. Update from... wrong one. Update from schematic. No errors. Okay. Now I have to like relay out all of the pins because they've all moved around, right? Well, if they just flipped, then I know that this one's power, right? So I can just move that. Right? Can I just move that? Done. And then this trace has to, this one right here has to go to the other pad. It has to go over to here instead of here. So I would just... I could just move it. Do I have to hit M first? I guess so. No, that's not what I want. What's the button to... Do I click the end of it? How come it's not behaving like it did the other day? Should I be able to just pick it up and move it? I was in the zone with this the other day, and now I'm not. I'm not sure why. Is it because I need to pick back copper? That might be it. Let's see. See, it's not letting me drag it now. Yeah, but I shouldn't have to hit G, right? Oh, that's odd. I didn't expect that to happen. Let's just delete it. And just do X from there. I mean, that works, right? I think one problem is I don't have the grid correct. So let's go down to 0.1. Then X. And yeah, we'll just... I can't make it around that. Really? Too close? What if I, like, get it close and then... It doesn't want to squeak through there. Yeah, sure enough, I haven't been able to squeeze through there on any of these. Okay, fair enough. So we won't go that way. Just undo, right? Okay. Okay. I don't know why it was saying I was violating something. I'd rather just actually delete this here too and go from the via. How do I get... Oh wait, it's telling me I need to connect it there? What is that line then? That is power. Wait, then I don't understand. Let me undo a few more times. That's how it originally was, right? Then what's this? That's power. What is this then? Right, that is the control signal. That should go to here. Then I don't understand this. Okay, now it's correct. Okay, I don't know. I don't know what this thing is. There. That's ground. So that should go. Okay. Actually, why don't I just... Would it be simpler to just delete this entirely? I gotta reroute all this anyway. Let's just delete it. Isn't 3 supposed to be bottom left? On this one, I rotated it. I guess I can rotate it back. Yeah, I'll delete all the traces and maybe it's on this side, it's the bottom left. But on this other side, I flipped it because I think originally the rat's nest was better. But now that I'm flipping it, I'm mirroring it, I probably want to flip it back. Yeah, I think it's just better for me to delete all these traces. Delete that. Yeah, we'll just redo all this. You know? So delete all of that. Delete that via. Delete all that. Okay. We'll just redo all of this. It's fine. Delete the vias. Okay, a few more to do. Notice the pad on the ground isn't on the outside. Did you fix it on both or just one? Yeah, it's the same thing that Everx is saying. I for some reason on one when I copy pasted, like I think I did this side first, and then when I copied it over to this other side, I ended up rotating it twice rather than well, I rotated it twice, so the ground ended up being from one corner to the other corner. Oh wait, I undid the footprint change too, somehow. Okay, well let me delete the traces first and I'll fix the footprint. I must have done an undo step. Maybe that's what you guys are trying to point out. So yeah, there's something wrong with the footprint again, probably because I did an undo. I hit undo too many times. But yeah, let me just clean up. We'll clean up all the traces first, because we got to redo them. All right, so that's one side clean. Let's clean the other side. Okay, getting there. I want to keep that one around. So we have this dog who's sort of dumb. she'll sometimes think that she's stuck in the backyard and forgets that there's a dog door to go through. And she'll just sit there outside barking to be let in, not remembering that there's a doggy door. So that's happening right now. The dog can't remember that there's a dog door. Okay, yeah, see, this probably makes sense for me to turn it around, right? So rotate that one twice. The rat's nest looks a little easier. But I'll want to move the silk screen around, right? What side are we viewing? Viewing it from the front, right? Flipboard view. So I'll want to move the silk screen down, right? Why is this silk screen... Wait, hold on. Let me undo a few times. Why is the silk screen upside down? Was that... Did I have the silk screen upside down on this board and didn't notice? Which side is this? This is this side. No? It's correct. I must have flipped it on the footprint? I don't know. Good night, Tezel. Seems our cat forgets it's able to open some doors on its own. Yeah, so it could be the clever way for the dog to get attention. Could be.
Hey, no, you're not barking at.
So what was she doing?
Oh no, was she outside? Was that her?
Yeah. Okay, the conclusion is that the dog was just afraid of the door for some reason. It must be that when I refreshed the footprint, it reset the location of the reference, which means the footprint might be wrong. The silk screen on the footprint might be wrong. I need to review that. This is correct, right? And that's also correct. Okay, the footprint's correct, so maybe just this, I need to refresh it. Okay, yeah, I just need to flip board view around. Yeah, and then move the silks, yeah, just move that down to here. And let's just hide whatever layer that is. User drawings or something? User comments? No. Fab? Yeah, we don't need to see the fab layer. Where did I put that? It's on the back. What if we just say back layers? There we go. And then remove the fab layer. Yeah, okay, that's good. Okay, same thing here. Just fix that, right? But put the silk screen in a logical position. Yeah, just fixing silk screens here. Actually, before I fix the silk screens, I should see, is this in a logically sound place, or should it be flipped around? I can't really tell. Actually, it should be flipped around because it would be easier to route the signal, right? Which means I want to kind of take this and rotate it around and put it down here. Right, so we'll place the ground up there. Basically, it's 180 degrees rotated, but it's easier for me to route the data in around to here, right? Which means it's probably easier that way, right? Yeah, okay. So that's easier like that, with the silk screen below it. Okay. 2 more. One more. Okay. So this should be somewhat easier to route, right? Oh, there's a trace I forgot to get rid of. Does that look reasonable? That's just power. I can get power from anywhere, wherever's most convenient, right? I kind of want to route this one first. Like that. Down to there. Okay. And then the data out should go to the data in. Like that. And then again, this data out should go to like this data in. This data out should go to this data in. So for someone who has no clue what he's looking at, what am I even looking at? What the components do? Well, you can see it down here in the second camera. Well, I don't have it lined up right. These NPs are NeoPixels, so they're LEDs. They're off right now, but I was lighting them up earlier. I want them to shine through the board so that, like, when you press a key, the key lights up. So the NeoPixel's like sitting under the key and shines. It's going to shine through the board. It's mounted on the bottom side here, but it's supposed to shine through and up through the key. And I had it backwards, so I'm fixing that. So this weird shape here looks like kind of like a little. It looks like a bar, but kind of fat on one side and curved. This is the these black components, which are the sockets for these key switches. So I can just pop one of these off, right, and show it in the camera. Center this correctly. So they're like, it's kind of hard to see with my camera, but there are 2 pins on the bottom of this key switch, right? I'll separate the key cap from the key switch. Key cap, key switch, right? Switch is the part that does the clicky. Key cap goes on it. There are 2 pins here. They stick into these 2 sockets. One right there, one right there. So I just push them in. That's what makes it hot swappable, right? Right above that, this is where we put a diode, which in our circuit we use to prevent the keys from being ghosted. The longer explanation for that. And then this, yeah. So the idea is we're looking at the back of the board. The socket is mounted on the back, and so is the NeoPixel. There's a hole, so the NeoPixel is supposed to shine through to the front. And we mount the key switch on the front. And I hope that makes sense. That's what we're looking at. But these 6 NeoPixels, NP1 through 6, have to be wired in a daisy chain. So the signal comes off the processor board here and runs over to the first NeoPixel, and then its data out goes to the data into the next one, whose data out needs to go to the data into the next one, and so on, right? To the end. So NP6 is the end, so its data out is marked no connect with that X there, right? So in addition to this data, which I don't really have a net name for, but it's just the data in. Actually, I have it for the first one, right? It's just called NeoPixel left hand side keyboard. In addition to that and the data out that goes to the next one, we have 5 volts and ground. So the 5 volts are shared. So easiest way to route this, connect them together, is to just kind of like draw wires from one to the other, I guess, like that, and do that on all the different pairs here, right? There. This one, I don't like how I did that one, so let me undo this one and redo it. Well, this one's giving me trouble. There. Makes sense? I'm glad it makes sense. Glad I can explain it in a way that makes sense. So yeah, each of these is one of the keys on the keyboard. All right, and then ground. I have trouble routing through there, right? I think what I'll do is use the front side to route ground between things. I need to get from here to here, though, first. What if I just go all the way around like this? I go from here and I go around, and then I go up and there. Wow, that trace is really close to the other one. Can we move that? Yeah, okay, so now clicking and dragging is working. It wasn't working before. I don't like how close to the pad that it put that. There, I like that better. In fact, let's clear the silk screen there. Why not? Okay, and then let me do the same thing here. So we'll go from here, wrong key. Go from here, go up and around, and then over and plug into there, and then I'll just make this, whoa. Why did it do that? Just do that, and then drag this one over like that, and this one over like that, just to make it look a little nicer. Let's bring that away from the pad. Let me do the same thing for this one. Just to, like, if we have the margin, might as well use it, right? Okay. So I need to connect the grounds together. I need to connect the powers together. The powers we can run on the left side, right? So I could go from here. I don't know why it's giving me trouble. I will just drag it like this. There. And then I can clean it up. Whoa, why did it do that? I don't want this weird triangle thing. Actually, it'd be nicer if it just put it there, right? There. We're gonna step, the silk screen will show up on the top of it, no worries. Yeah, and then connect it down to there as well, right? So maybe do the same thing here. So connect off of here, go down, and then over to here. And let's clean this up. Let me do the same thing here. We'll have this, whoa. I don't know why it disconnects the wires like that sometimes. Let's try it, start over again. It's messing up my traces here. I just want it to go like, yeah, like that. Close enough. Whoops. I clicked out of the window. You kind of want to make a shape like that, and I didn't do it well there. Right, this should be more like that, right? Only it's not clean. Let me try to clean this up. It's because of this edge here. Let's just delete this. Try to do that again. Maybe just make that a 90-degree angle to start with, right? And then X from here, maybe? It's not as good. We'll live with it. It's just not... I'm just a perfectionist, what can I say? And that's not a clean join there. Hey there, Nightshade dude. Line drawing connectors always seem to be terrible. How goes the key? Check it out. I got it. The prototype assembled. The only thing wrong is the LEDs are shining in the wrong direction. They're not shining at all right now because they're off, but there's a different reason for that. Why don't I just do that? Isn't that just better? Maybe drag this one a little bit down. I mean, there's sort of an angle there. Maybe we can get rid of that. I don't know. I mean, I guess it's fine. There's kind of like art in this, right? You know what? I'd rather have this go up to there instead. Yeah, there we go. I like that better. See, it's like there's some art in this. Okay. So I got the powers. They're not all connected to each other, though. Right. The easiest would be to run power from here, I think, back over this way. And then over to, like, yeah, over to, like, maybe this guy up there. That's probably the easiest. Why is it not wanting to go there? There. It's fighting me. Yeah, join there, and then we'll move this out a little bit. It doesn't want to join up there. Fighting me. There. That looks good. So yeah, now I just have the ground to connect. What's this one? Oh, those grounds are unconnected now. How did I disconnect the ground there? Probably because I had the ground originally going through here? Okay. Well, an easy thing to do would just go around, right? Like this, and then like this, and then go back to here, and then we can take the opportunity to go over to the other side, so via to here, and via back, right? There. And then front side copper, we can just... Oh, actually, I can just go from there to there on the back side. Oh, but we can't fit through this gap, right? That's the problem I had originally. Yeah. I'm thinking front side copper. And then we're just going to collide with that. But how about... How about I move this via a little bit? Like, down to here? And then... I can go, like, over... What was I thinking? Like... I don't know what I'm thinking. Let's undo this. Okay. Do I want to keep this pair of vias just to get ground over there? Or is there something better? Some boards look beautiful. Mine looks like a mess. Okay, maybe I'll do the easy part. The easy part I was thinking is that just we can always just go to a via immediately. So here to a via. And then this can join up with that other guy out here somewhere, and then just connect back to ground on that connector, because it's there. Whoa. How come it's drawing it like that? Anyway, pull this down a bit. I don't know why it decided to draw those as separate. And then same thing on this guy. We can just go from here immediately to a via, and then just join up. Like, we don't want an acute angle though. Sure, I can do that. That's fine, right? Or is it? Would this be better? Whoa. I messed that one up. Just delete that one. Kind of better to do that and then this join up with that there, right? Yeah. That looks nice. Okay. And then just follow the same pattern right here out to a via and then just join up with that ground. So X, V, click, and then join up with the ground. I guess we can go over to here. Right? Why go all the way down to here if we can just go over to that one? This one might be getting a little close, so let's move it up and around just to give it some space. And then same thing here with this guy. X, go to a via, and then just run. Oh, take that back. Undo that. We should run past this front side one and then via. There we go. And then I can comfortably like go around here and join up somewhere over there. Where exactly? How about just click there, terminate it, and we'll just drag this one down to there. This is more difficult than I thought it would be. There. Although I kind of want it to go a little bit further up. Ugh. Drawing lines is hard. Like that. Yeah, I want it to be like that. Okay, and then one more set of grounds to do. Okay, same thing here, right? I want to kind of go past the front side copper one via over and then go down and meet up with this guy somewhere. So like this one can kind of go out here and meet up with them. Right? And then here we can just complete the path. All right. Fix this guy. All right. You're gonna lurk with the cat purring in your ear? Don't fall asleep. Okay, I finished one half. It actually looks decent, right? I think it looks fine. Oh, these grounds are... Somehow I lost that ground connection. There. Don't know how I lost that one. Yeah, all the grounds on this side are connected now. Yep. Okay, so we got to fix the other side now. Is this one just a case of flipping this around twice? Yeah, already. Yeah, okay, and then just move the silk screen down. It looks better. So every time I have these boards made, it's like $15. So I have to decide, am I gonna like actually produce Rev B of this board, or do I just move on with what I learned? I haven't decided yet. Oh, old traces here. Let's get rid of them. Okay. Let's do the simple ones first, right? The data outs go to the data ins. Backside copper, so X here to there. X here to there. X here to there. All right. Okay, so power should do the same thing I did for power here, which is just use. Ooh, what happened there? That's ugly. What do I do here? Yeah, why not? I think that's what I had before anyway. Yeah, okay. So just use backside copper from one to the other, just on this side. Okay, so that would be like this. Why is it drawing a funny line there? I don't know. Undo that guy. Try again. And just, yeah, just run all the way over here to ground. Right? Nothing elaborate, just that. This ground connection's still there. Okay, cool. And then, same thing here with this ground connection. Just kind of run down and up. And same thing here. Just run it, come on, run down. There we go. And then back up. That didn't work out there. Let's fix that. Whoa. There. Cleaned it up. Okay. Yeah, so this one is an easy path to ground there. Okay. So connecting the grounds between one to the other, I can go all the way around, right? That's ground here. So I can just go down and around. Whoops. Go around and kind of meet up here. Let's clean this up a bit. Okay, and then around here, let's move this a ways away. This looks odd here. What happened there? Okay. And then power, I was going to use front side copper for that, right? So I should route the signal. Looks like I'm going to run across some signals here, though, to get there. What was the deal over here? It was a more direct path? Yeah, it was just a more direct path. Here we gotta cross some other neighboring. We have to cross some other things. So what's the best here? Go to a via. Actually, it'd be better to just go through or under this guy, right? Can I just go under him? I'm going to hit that trace right there, though. It's not a good idea. How do we get from there over to here without going through too many vias? Okay, begin when on the backside. Via once. Via twice. And then done? Yeah. Not too bad. Actually, yeah. We do have lots of things crossing each other here because of how the processor is flipped from one side to the other without me rotating it. Okay, anyway, that's the power, and it wants to get the power from over here. Hey there, Strager and friends. I'm fixing an error in my board. I had this prototype keyboard made. I've been working on it. The software works. I just mounted the LEDs facing the wrong direction, and I'm trying to fix that. I'd be ashamed if something were to, boom, happen to it. Yeah, I mounted the LEDs facing the wrong direction. So I'm fixing it. I fixed the layout, the footprint. That's what it's called. I fixed the footprint for the NeoPixel so that it's actually mounted in the correct direction. And because that involved mirroring it, I'm having to redo all the traces for the LEDs. So I'm making a keyboard. This is the PCB layout of the components on the circuit board for the keyboard. So we have our controller over here. We have two different ways to connect the two sides of the keyboard. So there's an audio jack and there's also USB-C. And then just because this is an early prototype, I don't want to have like all the keys that final product will have. So we just have 6, just so we can have minimally at least 2 rows and 2 columns, right? And like threw in a 3rd row because we had space for it. So we have 3 rows, 2 columns, and each key has a socket where we can hot swap. You know, I can literally just pull this off the board like that. And we have the switch with the keycap on it. Keycap is also hot swappable. This is a Cherry MX white. Put the keycap on, and then you literally just plug it back into the socket. And you can do this while the keyboard is powered and everything. No big deal. We just line up the pins right. Sometimes I don't line them up. Can't line them up. There we go. By eyeball. But yeah, that's what this is. And then right next to our switch, we have a diode, which prevents ghosting. And then we have this pixel, this NeoPixel LED, smart LED. And we just have 6 of those. Hey there, Romania Hate. It's going well. We just got rated by Strager. Hope you had an awesome stream, Strager. Pretty thin traces is 8 mil. We can measure it. They're not that thin. Let's go to grid 0.05. So they are 0.25 millimeter. I think that's well within the tolerance of the board house I sent it to. I think we can have traces that are half as thin, if I remember right. It just maybe looks thin because I was zoomed out a lot. But yeah, on the real board, they look normal to me. It's sort of a hardware software stream because I can flip back to the software side of things. So I added this a little bit earlier to test these 2 LED smart pixels. I added another constructor call to this type that represents the protocol to talk to a smart LED. And this WS2812 is I guess you could say it's the part number of the original smart LED that all of the NeoPixels are based on. and so they all use a similar protocol, and it uses programmable I/O with the state machine on this particular microprocessor that I'm using. So when we run this constructor, we get an object that we can use to write out LED colors. Literally, we write out the RGB values for red and green, put them in an iterator in Rust, and give it to this brightness function to apply a brightness to it, and give that to the right function to the smart LEDs, and it will light up my LEDs for me. So I did that, and to make sure that they're wired correctly. Even though they're flipped upside down, at least they're wired correctly. And now I feel compelled to fix the PCB to actually flip them around the correct direction. I don't know if I'm going to spend the $15 plus $5 shipping to actually have more boards printed. It's sort of a pain in the neck to have to do all the soldering, so I think I'm just fixing the PCB for posterity at this point. 0.25 millimeters sounds good, about 10 mil. Yeah, they're normal size traces. So what you're seeing here is the layout, right? And if I do the 3D viewer, we get a depiction of what I already have. So when I have the board house printed, I have them printed as one card that's twice as wide with these breakout tabs, and then I literally like break the card into two. So this is the right side of the keyboard, split keyboard, and this is the left side, and they're connected either with these audio jacks, or for some reason the 3D model didn't load, but there's a USB-C connector, right? And if I flip it to the back side, here's where we see our diodes and our sockets and our smart LEDs. So now they are pointing in the correct direction, right? This is the where the light is coming out of, and it's shining up through the board. They're mounted on the reverse side, right? So I had the footprint flipped, and so when I went to solder it, I'm like, I have to have it backwards in order to wire it correctly, which is bad. So these really thin lines aren't traces. It's called the rat's nest. It's a way for the CAD tool to tell me, hey, you haven't connected all the signals together. It's trying to say that, oh, that's an extra trace there. It's trying to say that, hey, you have a 5-volt connection here, and so the nearest 5-volt connection is over here on this end of the audio jack, right? So it's like trying to give me a hint saying, hey, you might want to create a trace that goes from here to there. Obviously can't go through this cutout or through this other trace, but we would end up like saying, okay, start from there, and then we'll draw it, and then like get it, this is where we get to play the game, like route your traces game, right? We need to get it over to where like it will plug into that pad up there. So like one way to do it would be go to a via, which means go through the board, and on the other side of the board, run a trace like close enough, like maybe up to here, and then via back, and connect there, right? And we'll make a cooler diagonal here. Why not, right? It's kind of a fun step to the process where I get to kind of be an artist a little bit and route traces around. Oh, how did I fit there? That was a lucky fit. Anyway, see how now there's no rat's nest line here because it's happy. It's like, oh, you've routed power there now. So I need to get power from here over to here. So an easy way to do that would be on the front side copper. First, I'm going to move this via a little bit out of my way. Move it to there, and then I will make another trace down and around and to a via here. And then connect it to there. And then it wants power over there, so I can just say, again, front side copper. Let's go from here and there and go down and around and just kind of have the same pattern here. A via to the pad. Yeah, this is KiCad that we're using. I'm having fun. I have the most fun maybe using a little bit of my artistic side, which is very tiny, but like, having fun routing these these traces. What's cool is I had the circuit board printed and I didn't have any trace problems. Everything worked, no short circuits. The only problem is I had the footprint of the NeoPixel wrong. So, you know, it's always an awesome moment when you have very few errors, right? It's like writing a program and having it compile first try, right? Okay, so these two lines are saying, like, I'm daisy chaining these LEDs together, right? So I've got 7 to 8, but I don't have a link from 8 to 9. So we need to get this pad over to here. What's the best way to do that? Maybe go around? Looks like we have a path there. So backside copper, from here we can just go around. And then through this, through here, and then back and around. There we go. I did it. Can't do the same thing here because this ground connection is in the way. Oh, wait a minute. We can sneak through if I make some room here. I can grab this and place it down here-ish. Move this out of the way, right? Yeah, move that. I don't want to get too close to this because this is going to be literally the edge of our board, right? But now I have enough room, so maybe I can sneak around here. Look at that. We're sneaking through. It's like we're playing that Tron Light Cycles game or Snake or something like that. Oh, wait. He's in our way. I guess we have to do a via. And then via back. There. It's like you can't hit a trace from a different net. You cause a short. Biggest board you ever done was 20 by 20? How big is mine? I think this is slightly bigger. No. I'm getting my millimeters and my centimeters confused. We have a 7.2 centimeter square. So yours was about a little less than 3 times as big, so about 10 times as big of an area. Yeah, this board is not that big. I keep hitting this with my glasses. What's this? 5 volt? Oh, I didn't finish this. Front side copper, I want to do the same kind of technique here where I branch off. Let's go back to grid point 1. Branch off of here. Oh, that's why. Okay, this guy is in our way. Well, shoot. Maybe it's better to go around here with power? No. Okay, I can at least do this part, right? I can say, give me a line over to here. Via, and then... Oh, is this the wrong signal? It is the wrong signal. Shoot. Undo. Let's do an easier one first. It's these column signals that are in the way, right? How did I deal with this on the other side? Oh, I brought that together so I have more room. Can I do that over here? Not really. I can move this guy out of the way. Like this. And then I can go here to a via. And then go over. Then I have plenty of room because there's no other copper anywhere near here, right? There. Okay. Actually, why don't I just, I was gonna say, why don't I have this be straight across, but then that would get these two vias too close. And it's fine. You know, it's fine. So front side copper, I can make like another connection out of here. And actually, let's go the other way. Let's go from here, like, and go around this way. Oh, perfect, because I can move this guy out of the way, and then we'll fit him in. Yeah, we'll just go around here. See, this is fun, I think. Yeah, boop, and connect. And then I'm going to move this guy a little bit down so that I can then branch off here somewhere and just hit that. There we go. And we're all unrouted. No unrouted symbols. You want to learn, you're currently a software engineer student at the university college, you currently teach you Java. By the way, you don't really like it. You're currently learning Go on your own and love it. I think it's amazing. Oh, thank you very much. So I'm doing Rust, not Go, but Go is a pretty good language too. For manual routing, if you limit the direction to roughly horizontal traces on one side and vertical on the other, then your routing gets easier. Yeah, I haven't gained those skills yet, so my stuff is going to look like a horrible mess. But I think of it as sort of like art too. Might need more vias. Yeah, I don't think it really matters practically if I have a lot of vias, because I think, I don't know, I can try to see over time if it's costing more, but like the board house sent me no questions, had no problems, they just printed it. It's almost like it was automated. I just said, here are some files, and they said, okay, here's some boards. Let me do the, let's save, let me do the DRC. Oh, I do have an error. Okay, what's my error? Okay, I have something too close somewhere. Where is it? Here. Okay, that got too close to the cut, so we have to move it away. Rerun the DRC. Now we just have warnings. Okay, so it's like there's some like really small bits of copper we can just delete. Yeah, really, really tiny pieces of copper that don't need to be there. Yeah, very small pieces that don't need to be there. One more. There. I like to get to 0 warning, 0 errors. If you haven't noticed. You buy, yeah, this was, I made this at JLC PCB. Buy boards for, how do you get it for $2? Mine cost 15. What did I do wrong that it cost me $15 instead of $2? Rust was also in your plans, so you chose Go? Eh. They're both fashionable. So is Zig, JavaScript, TypeScript. I'm sure Strager would say C++ too. And sure, why not? Those are all good languages. Without shipping. No, mine was 15 and then another $5 or $8 shipping, depending how fast I wanted it. Maybe I picked some option that made it more expensive. This looks like I could move things around and not need so many vias? Let me think about this. Well, they're going to hit somewhere, right? There's maybe nothing I can do about that. I can move this via a little bit. Like in between there. This I can make a little bit nicer, I guess. Hold on. So I can pull that down and then pull this down. Like that. Delete this tiny little guy. Then it looks more artistic. There's like a little Y joint. just visually inspect this to make sure. By the way, I what is it called? The mask. I burned off some of the mask here when I was soldering because I caused some bridges here because I don't have enough flux. I ordered more, but yeah, I did a really bad job on these pins, and I ended up like stripping off some of this mask on these boards. Oh, that's kind of close. I don't like that. Let's move this away. I mean, if we have the margin, we might as well use it, right? Like, there's no reason to bring these traces so close together, right? We can bring them further apart and, like, make use of all that margin that we have. Like, that doesn't need to be so close to the diode, right? We can move this. I can move this a bit. This via could be up here, for example, and then they kind of just pass each other. This is sort of weird. Why don't we just move this one up to there? Right? Why not? Move this down to here. Whoa, what happened there? There. The drawing tool is weird sometimes, you know? We can do that because it's on the front side. We're getting kind of close to that edge cut, so let me move this out. This is kind of close to that diode, so we'll move it up. That's kind of close to that diode. I mean, it's fine, but if I can, why not do some stuff like that, right? I can do it. Oh, that's a bad one, right? We don't want that sharp angle. Let's make it a Y. Like that. That's better. And this bend here we can improve on, right? Just bring that down, and then this could be brought over to there. This could be brought down to there. That looks nicer. Okay. I have the margin for it, so why not do that? I don't know. There's a lot of art involved here, right? What I'm kind of looking out for is if I have a trace too close to a cut, or a trace too close to a pad, right? I think it's fine. Run the DRC one more time and move on. Okay, I have like maybe half an hour left in me. So why don't I just save this and go back to the software for a bit? By the way, here's our schematic. I don't have all the pins brought out from the microcontroller, but basically it's a keyboard with a key matrix, so there's columns and rows. And we have these supposed to be per key LEDs that are in a daisy chain, so we only need one LED for that. And then to talk to the other side of the split, I use a UART, right? And the UART actually goes across a couple different options we have. USB-C here, or I use an audio jack. So what I've learned is in the custom keyboard arena, it's sort of a split camp. Some people really like the audio jack. Others think it's an aberration, an abomination, because why are you putting power over an audio jack? So they say use a USB-C instead. And that's fine, except for it's really a tough thing to solder. We do have extra conductors if we ever want to use them in the future. I'm just not connecting them. And you don't want to accidentally plug it into your computer, because your computer will be like unable to interpret your UART signals. I am using the power appropriately, so that's a good thing. Yeah, I said earlier I chained my smart LEDs together. It's a smart LED because there's a little microcontroller inside of each, and this single bit signal going in is kind of like a self-clocking protocol documented in the datasheet. But whatever data you put into the first pixel gets shifted out to the second, third, fourth, all the way to the end of the daisy chain. So if we write 6 different color values, we set a color for all 6 of them, and you just write them in the correct order. Pretty simple circuit there. This is the fundamental thing of how a key matrix works. You have columns and you have rows. So you see each, I sort of have this rotated 90 degrees to fit on the paper. But the idea is when you press a key down, it connects a column to a row, right? So if you press switch 1 down, you'll connect column 0 and row 0. If switch 3 is pushed down, you're connecting column 0 and row 1, etc. And that's how you sense if a key is down. We would drive a is that what I did? Yeah, drive a column low instead of, drive a column low, and the rows are weakly pulled up inputs. So if the switch isn't held down on any column, if no switch in that row is pressed down, then we always read a 1 on the row. But if switch 1 is down, when we drive column 0 low, it'll go through the switch and out row 0, and we'll get a low on row 0, right? And these diodes are here so that we don't have current go through a switch and then back up through a different switch and look like we call it ghosting, or it looks like you press switch 2, but you really pressed a combination of switch 1, 3, and 4. The diodes make sure the current only flows in one direction. And you want it pointed towards the ground. And since we're grounding the columns when we're sensing, it's appropriate to orient the diode that way. Basically, that's how a key matrix works. And the other side of the keyword is just mirrored, right? It's the same except for these two are flipped. But essentially, it's got the same circuits for the LEDs and the switches. Anyway, we're done working on that. Close that, and let me check in these files. So, right, I deleted one footprint and made 2 new ones out of it. And then I updated the schematic in the PCB to match. Let's check that all in. So we're going to say fix bug in NeoPixels being upside down. And so we're going to say clone the NeoPixel footprint, making one clearly reverse mount and shining through the board with cutout. And making the other normal mount with no cutout. Okay, and then it's update board to use the proper reverse mount NeoPixel footprint. Reroute all traces. What's the word? Reroute all traces related to the NeoPixels. All right. So again, I don't know if I'm going to actually print this board revision, but I at least wanted to correct it. With the diodes, you have to be careful about reverse bias current, which you, well, not really, because I think these are 100 volt, and I can't get, or it's not gonna sort the microcontroller is not gonna try to drive too much current through the diode when it's reverse biased. Yeah, it should work fine. What would I have to do to reverse bias those? I'd have to be pushing a lot of current, but it's a very weak pull-up right now. So yeah, I don't think it's an issue. 20 squared centimeter board was $20 for 5. $12.73 for the solder paste, $22 for the shipping because it was so big. Oh, reverse leakage current. I have no idea how much current this thing is sucking now, but I could measure it. I have the USB power measurement tool. Conducts in the other direction as well, but only 25 nano amps. I don't even think I'd be able to see that. Oh, hey, Sure Shock. I just noticed you said hi. I missed a bunch of chat. I'm sorry about that. Okay. I have like 20 minutes now. So working on the software side of things, we can reverse this back. I think what I'd like to do is get the keyboard reports to go from the right-hand side through the left back to the host. Because right now, if I hit keys on the left-hand side, they come through. But if I hit keys on the right-hand side, they don't. Now, this guy is getting messages from him whenever I hit a button, but it's just not doing anything with it because they're just log messages right now. So one thing is I have to distinguish between a log message and a keyboard report message. And then for keyboard report messages, I have to like go through the same logic I have now for when I'm actively scanning the keys like that. So first things first, the communication between boards, right? Where do I do that again? It's in one of these functions. It's a poll peer serial. I think it was here, yeah. Yeah, see right now what we're doing is we're reading until we get a new line, and then we're just doing a log message with whatever the string was that we got. And we just assume that it's UTF-8 here, right? So to be most efficient, I would just move to binary instead of a text, right? Good night. Look, I got a Rubik's Cube. So the current thing is we read until we get a new line. If I go binary, then I need some other serialization technique. Like maybe the first byte would say how many more bytes there are in that message or something like that. How about for now, I'll just keep it simple and I just keep this logic as is. And after we read the line and convert it back to UTF-8, we go by like what the first maybe word is in the line. And if it says like log, then we do a log message. And if it says key, then it's a keyboard report, something like that. Because it sort of matches what I had on, was it poll USB process control buffer? Next here, where it also scans to the next new line, and then it looks for like the word program or greetings. Yeah. Okay, let's do the sender side first. So that would be in where? In... Can't remember. Let's just look at run from the very top level. No, that isn't the very top level. The very top would be what? Main function? Keyboard, new, and then run. So in new, I set up the logger, right? There's the peer serial port, and it has a transmit ring buffer. Here's the logger. There's a serial buffer writer, right? So there's another ring buffer for... How did that F get there? We removed an errant F. So the logger is given a ring buffer writer, and we always write to it. So where's the reader for that ring buffer going? Host serial buffer reader. Okay, here it is. If we have data in the host serial port buffer, it's not really the best name for it, is it? This should be something like log buffer reader. Yeah. Yeah, I think it should be called let me fix the name on this. This should be log buffer reader. And this isn't correct either. This should be make a ring buffer for diagnostic log data. So it's log buffer reader and log buffer writer. Because it's given, the writer is given to the logger, definitely. Okay. Okay, so I want to keep this alphabetical, right? So it really belongs there. And the declaration, it really belongs up here. Okay. If we have data in the log buffer and we received a greeting on the peer serial port, transfer the log data to the peer. Okay, so here's where I want not just to push the data, but like push the data with a special prefix in front. So I need to put a prefix in front of this. Guess. Hopefully we don't blow the ring buffer when we do this. If we log fast enough, I could end up not being able to write an entire log message in there. What's the worst that can happen? It might get truncated, so it just get ignored, right? So it should be fine. As long as we're pushing in one step. So that tells me that yeah, that's a slice. I'll have to do a format? No. Yeah, I think I do want to do a format here. Yeah, but this has to be interpreted anyway, right? As a from what is it? 2 UTF-8 common. I can't remember. Let's just search for it. UTF-8. Alloc string from UTF-8 is fallible. Oh, yeah, I can just do that. Just copy that. Just put that in there. So here's where we just put data. Right, and then instead of doing info, we're going to like make a message out of, well, make a new message. Well, did you get a logic analyzer? No, I haven't needed a logic analyzer badly enough to buy one. It's a cool article. It uses a Pico as logic analyzer. That's cool. Neat. I think I'd be interested in that if I was looking for one, but I'm not really looking for one now. But thanks for the link. So instead of info, I think I want to do format. And I want to just keep it simple. Log space and then the log message. And I do not need to trim that. And then this becomes message. Well, we're gonna can I do just as bytes? Or is it 2 bytes? Is it as slices bytes? I forget how to turn a Rust string into bytes. Oh, is it because it doesn't know what format is? Hold on, what? What's the error? Oh, I imported the wrong thing. That one. Okay, now that should be a string, and now I should be able to do as bytes. Is it not as bytes? Or is it 2 bytes? I can't type. Okay, I don't know what it is, so I'm gonna have to look it up. Rustox. Sure. Bytes. There is a as bytes. Okay, it just didn't give it to me at first, did it? I had to do... Oh, wait a minute. I don't want bytes at this point. Shoot, I don't want that at all. I just want the message there. It's down here that I want message as bytes. There we go. I guess we always want to pull the data, right? Oh, hold on. What if there's more than one message in there? Yeah, this isn't gonna work because there could be more than one message in the ring buffer here when we peak. Okay, I'm not sure how to do this easy. This is going to take me longer to think about, because I have to, like, possibly reassemble messages here. So I might want to have a string that I'm building and just keep going until I see a new line, and then trim there, and then send it like that. Is there a format line? No. I don't know how I got there. Oh. Okay, anyway. Oh, I was manually doing character turn line feed before. That's what it was. I'm like, I can't remember. I couldn't remember how it would represent the end of line before. Okay. I'm gonna have to have some state in self, like log reassembly buffer or something. Or something like next log, peer log message or something. I have peer log. How is that being used? Oh, I'm already doing it here. Oh, this is on the reception side. So that just means that this moves, right? Well, no, it has to be in both places. Yeah, so I need to, okay, I got it. I need to do a similar thing here. This might need to be renamed actually peer log. Because it's not just a log anymore, right? It's going to be, it should just be peer message. It should, okay, peer message in and peer message out, right? Yeah. So let's rename this one to be peer message in, and then I'll have an out as well. Okay, find all that. Cool. And then we need to add a peer message out, also an empty vector. Okay. Yeah, so I'm gonna do the same kind of thing in the other place. Up here. What? No, this doesn't go there. I forgot where I was. Where was I? Pole USB? Yeah, right here. No, this isn't the right place. I can't remember where it was. Oh, it wasn't pole USB. It was pole peer serial. No, it wasn't that either. Was it just in run? I can't remember where I was. Okay, let me think. It's here somewhere. Is it in pole, right? Pole. It's not here either. Maybe it wasn't pole USB. I can't remember where I was. Well, okay. How do I get reoriented here? Go back to here and search for log buffer reader. Yeah, that. It wasn't pole peer serial? It's really not the right place to do it, though. This has nothing to do with the peer serial port. Yeah, these don't really go here, do they? No, this one does. But this one does, but this does not. This should, like, go somewhere else. Let me put a note here. To do. This part doesn't really have this really doesn't have, this really isn't directly related to the peer serial port. So it probably should be done somewhere else. Okay, so it's in a pole peer serial. So this kind of deal here would need to be done here. So if we have some data in the log buffer reader, then try to extend peer message out. This isn't right either. It shouldn't be called peer message out. It should be like log message out or something. Okay, let's whatever it's called. It's gonna go to peer tix buffer writer. Correct. Okay, so then this shouldn't be called peer message out. How come it's not? Oh, because I'm not hitting the right button. There we go. Let's just rename it here. Log message out, I guess. Hey there, A squared. I'm kind of getting stuck on something here. Like I have ring buffers, and I also have these vectors, and I'm kind of getting confused between which one I should be using at any point. So the thing is, our logger is currently writing into a circular buffer of bytes. But really, it would be more convenient if it was a circular buffer of strings, or just a vector of strings, really, or a vec DQ of strings, because we have to wait until we get to this point. Actually, no, we don't really need to wait till we get to this point. Maybe the logger. Never mind. I think I'm just getting tired. Can I work through this, or do I need to quit before I fall asleep? I can do this. So we have the next log message we're going to send out. I don't want to extend from slice though, do I? I guess if we end up draining it, it's okay. So this will go the same in all 4 places. I'll probably want to make a subroutine out of this eventually, right? If we find a new line, then we know the length of the log message. We don't need to do this step actually. I don't need to do this. I can just do a, actually I do, because I'm going to use format which takes strings, right? All right, so then we're going to make sure it's UTF-8 compatible. And if it is, then I'm going to do this over here. Delete that. This shouldn't be data len anymore, it should just be len. Right? No, no. We always pull, and I'm going to do that out here. There we go. So, we peek into the log buffer reader. If we get some data, then we add that data to the end of log message out, and then we scan for a new line in log message out. If let's say we don't find it, then we at least pull the data out of the circular buffer that we moved into log message out. But let's say we did find a new line, then we figure out how many bytes there are in the message. Oh, I'm going to want to trim this, aren't I? We're going to prefix it with the word log, and then write that out to the peer. Yep. Hey there, Quantum Apprentice. How's your stream? I'm doing a combination hardware-software stream today. Look, I got my prototype keyboard back from the board house, and I populated it with soldering, my mad soldering skills. And I'm now, I did a little bit of board rework because I made a mistake on the board. And now I'm back onto the software side again. I'm trying to get it so that I can press keys on both halves. Right now, if I hit keys on the left-hand side, they come through as numbers, but the ones on the right-hand side don't, because I don't have the protocol set up. Just finished a Pi game. Nice. Yeah, so this is my 12-key prototype keyboard. And I'm working towards getting the right-hand side working as a keyboard rather than just as a test platform. And right now, the data that moves across this longish wire here from here to here is just diagnostic log messages, but now I want to multiplex it with actual keyboard reports. So first I need to like prefix every message I send with either log or key, and then if it's a log message, then send it to our log stream. But if it's a key message, actually turn it into a keyboard report to send to the host. So I think I did this correctly. Let me make sure. So if we have some bytes from the logger, we pull it out and put it into this reassembly buffer. And if we find a new line in there, then, and we can, we'll eventually drain it out, right? But if we can convert it into UTF-8, then we prefix it with this log space, and we write that out. Oh, this is where I need this new line here, right? Actually, if I don't trim, it'll have the new line in it, and then I don't have to put it back in there, so that's perfect, right? Yeah. So then the receiver part has to be updated for this. So the receiver part would be actually the same place. It's actually here. I guess I can leave that as is. We'll just see peer and then log and then the message if I did this right. So build it. Make sure I got it working. Be a full keyboard, but for testing, differs only has 12 keys. Yeah, so special keys for stuff. It's for debugging, really. So this is the first time I ever made a circuit board. So I knew I would make mistakes. So I'm like, do I make mistakes on a full-size keyboard with a lot of soldering, or do I make mistakes on a small keyboard And so the answer is make mistakes on the small keyboard, fix mistakes so that when I do the real full-size keyboard, I will minimize my chance of failure. Yeah, peer, but just log. Well, this is gonna go soon. This one is temporary. This is just so I can distinguish messages that come from the primary board versus the secondary. You'll see in a sec. So over to here. Actually, I can show this as it's running. See, when I press a key here, it has a log message, but it says peer in front, and then this other prefix. So that's the primary board's timestamp, and that's the secondary board's timestamp, and they're going to be slightly different. They do reset near the same time, so that they're within a 1/10 of a second. But if I hit a key over here, you see this inner log message, but not the outer one, because this is coming directly from the primary board. So let's Control-C that one. Program again. If I did this right, then we'll just have this log prefix in front of everything. And then I can now multiplex it with keyboard reports. Okay, this thing where we have to wait, so what do I do while I'm waiting? BS what I'm doing. How fast is the communication over that audio wire? It's 115 kilobits per second. Hey there, Anakin Luke. It's not 4 a.m., it's only midnight. You meant one is missing the colon? Yeah, well this colon here is only temporary. Okay, there we go. So now primary board, it's just a plain message. Secondary board, put the log in there. So what I'm gonna do is I'm going to split the string at the first space and see if it's log, then it's a log message. If it's a keyboard report, then we won't actually print this out. We'll actually route it to as a real keyboard report. It's a modem? Actually, yeah, it's exactly a modem. We're using the UART. I have this set up in the new function to make a UART. So we're setting up the pins that I have these two connected on, the data pins, as a UART, and then I enable it with this configuration. 115.2 kilobits per second, 8 bits, no stop. I think it's no parity and with 1 stop bit. So it's either like UART or SPI or I2C. You need some kind of protocol, hardware protocol. And I just picked UART because it's convenient. You hear random letters? It's what does UART stand for again? Universal Asynchronous Receiver Transmitter. Right? It's a hardware device for asynchronous serial communication. It's convenient. Asynchronous is convenient because we don't need to have data ready to send on every clock cycle. We just send it when we need to send it. The downside is that it's if you want to send more than 1 byte, you have to send the first byte and then wait for that byte to be sent and then send the second. So you usually have a some kind of first in, first out buffer or ring buffer or something like that. And if you overflow that, then you lose data, right? You simply can't send everything because you can't hold on to it. Yeah, it's a protocol for talking over a wire. And you only need 1 wire per direction. So if it's half duplex, like 1 direction only, you only need 1 wire. If it's full duplex, you use 2 wires. So literally, this audio jack, there is 5 volts on 1 conductor, ground on the second conductor, and then the other 2 out of the 4 are the UART transmit and receive. All right, so going back. Okay, so here's the important part, right? We don't want to do that for every message. We want to look at the first, what is it? If message dot starts with, or what is it? Is it like a split or prefix? is prefix, strip prefix, right? And the prefix would be log space. If let some log message equal message strip prefix log, then we're just going to print the log message. So let me make sure that works. So I'm just doing incremental changes here. Because now I'm going to introduce a message which isn't log, and that will be an actual keyboard report. Control C, please. Okay. Reprogram. Why is it not connecting right away? I don't know. Something in my Windows setup, sometimes it doesn't connect to the board right away. The intent to have separate PCBs for anything? Yeah, so it's... I'm trying to make something like this corn keyboard, right? It's a split keyboard with a cable connecting the two of them so that you can... I can place them at however, like, spacing I want. Only this is a very small prototype version of that. Okay, so reprogramming... Now, now we remove the log and we're only printing the pure log message, right? Okay. So then the next thing I want to do is say else if let some key message equal message dot strip prefix key. I guess we need to store it somewhere because we can't actually report keys until we get to pull USB, right? And we get to, oh, wait, there's a keyboard report. We can use that. Right, we can just dump it into key codes. Or what I can do is I can have I can have the right side send a key report to the left side and then merge it there. Right? How about just key codes? Okay, it's going to be really inefficient, but right now the protocol is a text line, and so we're going to have to convert to text and then convert back, right? So let codes equal key message dot split Isn't there a split? A split. The pattern is comma. And then that's an iterator, right? So then map. What is it, like U8 parse? I forget how do we parse numbers again? I forget lots of things. When in doubt, just Google search it or DuckDuckGo as the case may be. So Rust parse U8 from string. Is this the right question? No. Is this it? Ugh. I thought it was parse. Okay, I'm getting off into the weeds now. Is it just parse? Oh, it's parse with a turbofish. Okay, so it's string parse turbofish U8, which we probably don't need in the end, right? And then we'll have to like unwrap that. Okay, I don't know how to do this with just function names, so I'll just do it with a closure. So code I need to hit enter here so I can actually see what I'm doing. Dot parse dot unwrap. And then collect vector of somethings. So code should be a vector of U8s, right? Okay. So then I think I just append, well, I'll need to have like local key codes and remote key codes actually. Generates a regex for natural language. Auto regex XYZ. Huh, interesting. This can be a single character. What if I have something called peer keys? Wouldn't I just, yeah. U8. Why don't I just do that? I have a peer keys and I combine them whenever I make my keyboard report. That's the easiest, right? So peer, here we go. All right. Then this is just self.peerKeys. Easy. Okay, so then I have what keys the peer is holding down. So I need to both report them and then I also need to combine them. So in peer poll USB, we do our key scanning. Well, no, here we go. Is it this keyboard report? I'm just continuously updating it. Ah, here it is. It's this not equal thing. Yes, so right, I build this key codes, right? So after doing our local scanning, so we'll just say combine with peers. Combine with peer keys here. So for code in self.peer keys, key codes dot add code. Right? Yeah, exactly. So now I have to report them if we are the secondary board. So that was one of these, right? Wasn't it where I kept the note? I can't remember which one it was. Was it here? Yeah, here. So it doesn't really belong here. I guess we'll just put it in here anyway. Really, this comment should go here. And then we should have another comment here saying, if we have, actually, we don't want to constantly send it. It should only be if it changes, right? Then I don't do it here. So back up, back up, back up. All right. Oh, intimate with the USB spec? I read it a few times. Not that intimate. You only need to read the 6 books if you want to know about all of the different aspects of USB, like protocol versus hardware, down to like electrical, and then there are all sorts of, at the protocol layer, there are different classes of devices. So I skimmed through the main spec for protocols, and then I skimmed through the HID and the basically the UART, the CDC spec. You don't know why it isn't used in Wi-Fi to extend range? Differential signaling was a game changer? Okay. Why would it, how would differential signaling extend Wi-Fi range? But differential signaling is when you have 2 wires instead of 1, and they complement each other. What does this have to do with what I'm doing? Nothing? I don't know. Okay. I guess what I want to do is, oh, we already have a keyboard report. Okay. So I can use the same code I had to see if the keyboard report changed. Where is that? I think it was around here somewhere. It was here. Right, this previous report. Okay, yeah, exactly. We can do it here. So right now we're just logging it, right? What we can say is if we're if we're the secondary board. How did I do that again? If self-received greeting, that's what it is. If we've received a greeting from a different board, that means we are a secondary board and we need to send them our key report. Right, so then this would be similar to the other place where we do this received greeting thing. I want to formulate a message and send it to the P or TX buffer writer. It's exactly what I want to do. So, but the message will be, instead of a log message, it'll be a key message. And then this message will be key codes dot, well, let's just make a method for this. Like codes. And then I forget how you turn an iteration into a comma separated list. Is it join? Well, won't know until I get the right type here. This is what I want, right? It takes an iterator? That's experimental. That works with a slice. I can never remember this junk, right? Like Rust, a join, iterator, into comma separated. My mind is blanking on how to do this. Can collect make a comma separated list? One may produce a string by collecting into a vec and then joining the result. This unnecessarily allocates. Okay, so what's the answer? You could use inter tools. You can do fold. Okay. So there's a vector join. Is that what it's saying? Oh, because it works with slice. Yes. Okay. Got it. Okay. So then, right. I could do, exactly. I can do a map. To string, right? So I'll just do it this way. Code to string. Dot collect vector of figure it outs dot join with commas. I just need to define this codes method. All right, let's do that. Pub function codes returns an implementation of iterator with item equal U8. So then this would be like just key codes dot iter dot filter code where code is not 0. Hold on, how do we do this format? Key codes. Oh, it's literally just next, so I can just do iter.take next. Next starts out at 0, correct? Well, it's going to be defaulted, so it's just next. Dot cloned, copied. Self. Forgot that part. That's the important part. Oh yeah, so there's going to be a lifetime. You can add it, yeah, so plus this lifetime. Okay, and then back here. I forget, again, how do you convert, let's just ask Google. Ask the internet, Rust, convert U8 to string. Or convert integer to string. Convert, that's string to int. How do we convert? There. I don't want a blog entry. I thought it was to string, but then it's whatever takes, what is it, radix? I forget this stuff, you know? Or is it just format? Okay, maybe if I just import it, it'll just work, right? Okay, and then what? This needs a double quoted comma? Okay, that works. This will work 100% of the time equals, yeah, exactly. Convert ASCII code to character. There's a simpler way, I thought, that, or there's a better way to do this. I mean, this works, right? I guess format would be another choice, but I hate to nest formats. I'm already, it doesn't matter. I might as well just do it. So what? No, that's, this'll work. I'll clean it up later. So this will send the peer a key message. Oh, I need to put it, definitely need to put a \r\n at the end. Join them with commas, a comma separated list of numbers that it then sends to the peer. And then that gets reinterpreted as a key codes, which gets combined, right? Let's just see if this works. Control C, program. Here we go. Yeah, I'm converting literal int 5 to a string 5, exactly. I mean, this all changes later when I use a real serialization technique later. I'm just being lazy. Oh, it crashed the main board when I did that. Okay. Okay. It crashes the main board, whatever I'm doing. So let's look for a bug. Probably when I unwrapped the parsing. So let's not unwrap and let's just print it out and see what we get. Okay, I literally need key. There we go. It's probably this unwrap where we're crashing, right? It's not parsing as a U8 anymore. So how about we just print, whoop. We'll just log it for now. Key message. Build. Program. Using a text protocol just for simplicity? Yeah, just to get started. Yeah, I don't look at the screen very often, sorry. Okay. Wait, it's putting them... Oh no, it's key 31, or it's key blank. Okay, so then what's the problem then? If I hit all keys down, it's... Okay, I mean, it's forming the string correctly. So what did I do wrong in the parsing here? Split on comma, map it, code.parse u8, and then collect it. Does parse u8 not work like I think it should? So I think this unwrap is panicking. I don't know why. What could it be? What could it be? Getting an empty string after splitting? Well, if it's an empty string, then the iteration will be empty, and then the vector will be empty. It could be where we're using pure keys. What if I just don't assign it to pure keys right now? What if I just do that? Yeah, I get a warning from that. It's just saying I'm not doing anything with it. And that's fine, right? I need to be able to type correctly. It's like, hey, you're not using that thing you made. I'm like, yeah, I know. Uh-oh, am I being rickrolled? In a string? Thinking the iteration might have a single empty string. Which doesn't parse, probably, because I didn't trim it. That's probably it. Yeah, I bet that's it. I didn't trim the string. Right? Did I forget to trim the string? I did forget to trim the string. Trim. That's probably it, right? It's seeing that new line. It's like, I don't know how to make a number out of a new line. You know, I'm creating problems for myself by having this weird, like, text-based format where I should just put the time into making it just a binary protocol. But I'm just being too lazy, and it's just costing me in the end. Okay, it was okay until until I released the key. Okay, if it's an empty array, it's crashing. What would it be? What would an empty array do to it? I don't know. It'll strip this prefix off. This would be empty, and then wouldn't this just end up giving me an empty slice, and split an empty slice is an empty iterator, right? Make sure the array is empty instead of an empty string. It will be an empty string, but when you split an empty string, you get nothing out, right? So there's nothing to map. Collect returns an empty vector, right? I don't know. Wait a minute. Split gives me an iterator with an empty... Really? Well, that's horrible. Let's see what it says. Oh, that's bad. Okay. Yeah. So would we skip empty strings then? I mean, I can do that. So it'd be split and then it would be filter. Code where code dot isn't empty, right? Not. See, the intuitive interface to me would be you would get an empty iteration. That you wouldn't get a single element which is an empty string. That just seems weird to me. That I had to filter out empty strings. Insert from the docs, yeah. That's probably it though, right? Yep, that was it. Okay, then let's connect this back up. So I don't need this, I mean, we're going to assign it to self keys. I don't need this info anymore. All right, and then Should be good. Oh, I don't want to log it on the other end, do I? I mean, I guess I can. So we're going to have both the keys and a log. Then we'll know where the key came from at least. Okay, yeah, this will work. I can tell you I'm not doing my best work right now, but hey, I'm having fun. It's a hobby, right? You wouldn't want A, B, C, D, E split F to return empty. Sure I would. Why not? You get whatever you pass in. Since there's nothing to split, you get a single element. Oh, I see what you're saying. But I mean, I think empty string should be a special case. Right? If there's nothing there, then I shouldn't get any element out. I understand that you're saying that, like, if it's not an empty string, like A, B, C, D, E split F should return A, B, C, D, E. But empty string split should return nothing. Not even an empty string. Where mistakes happen? Okay, so it's just I would have liked it to be different. Hey, look at that. So now, how did that happen? So now if I hit over here, I get 1, 2, 3, and over here I get 1, 2, 3. So now, to make it interesting, what if we make the left side be numbers and the right side be letters? And then I'll check this in and I'll go to bed. I wanted to get this scan key codes because I want to look at that again. So put that over in this window. Okay, so the 1 through 9 is 1E, so what's A? Okay, so 4, 5, 6, 7, 8, 9 is what I want. Easy enough. We'll just again go by if we are the primary controller, I guess? I'm using this function too much. I shouldn't use is primary controller. I have to reevaluate the use of this function. Anyway, where we're polling keys, where do I do that now? Let's just poll. Scan keys. Right, so these codes that we add, right? Let's just hack this in, right? So let code base or something, or let base equals if self dot received reading 4 else 30, and then I'll just have like this be base, and this is base plus 2 and base plus 4, base plus 1. Totally hacking this in. Build that. I have an error. What is the error? No semicolon. Thank you for the follow. Control C, run it again. Okay, reprogramming. Isn't it cool how I can reprogram both controllers simultaneously? It's better than what QMX can do, or QMK. For QMK, you have to do them both separately. But I can do them together. Okay, so cool. I think it's working. So if I go to my other window, so 1, 2, 3, 4, 5, 6, A, B, C, D, E, F. Yay! It's episode 3 of my YouTube, but want to say hi. Well, hello. Marco Silva. We're on episode 12 right now. So if you're on 3, then I probably don't even have any keyboard yet, right? I probably just have the raw controller. Probably the last thing you saw. But yeah, now, spoilers, we're going to have this actual circuit board that we built. Cool, so I have a fully functional keyboard that has the numbers 1 through 6 and A through F on it. Where's the Q key? I don't have one anymore. I have 1, 2, 3, 4, 5, 6, A, B, C, D, E, F. Cool, I'm happy with this. I need to clean this up. So I hacked in a bunch of stuff. I have this as a hack. Let's just put fix me's. Each side of the keyboard should define its own separate codes in a clean way. A cleaner way that we eventually will want to make programmable through some kind of UI. Okay, that's one hack. And that hack kind of extends to all of these codes, right? Yeah, this whole thing is a hack. We always want to do that. That's good. We always compare. Okay, and this is the second hack, right? So this is a fix me. Use a I think I'm going to end up using a SERDI thing. Use a real proper binary protocol rather than text lines. Okay, and then that gets repeated elsewhere, right? So that was in poll peer serial? Yes. Fix me goes there, use a real proper binary protocol rather than text lines. So we're using text lines between these two guys, and we're going off of the prefix, like if it's log space or key space, whether it's a log message or a key report. And where do I generate these things? That's where I generate that and where I receive that. Where do I generate log? Here. Okay, so this also needs a fix me. Use a real protocol rather than this junk. Okay. So you're making a split keyboard, are you already using one? Yeah, I'm using this corn keyboard. So it's kind of like my model. I'm getting a lot of inspiration from the corn. And I had that built for me. The end goal is that I want to kind of make my own and replace the corn keyboard. And I want the firmware to be all my code in Rust and not QMK. It's also a custom built one. No, it wasn't my build. I ordered it. And it's based off of Fustan's corn. So in the end, I'll be replacing Fustan's keyboard with my own and replacing QMK with my own. And that'll be cool. I'll have my own keyboard made completely by me. Well, based off of the work of others in the Rust community, I should say, and based off of the good people who make KiCad and all the libraries that I've leveraged. So not completely from scratch, but you get the idea. Okay, I think this is a good stopping point. I have both sides of the keyboard working as a keyboard. The scan codes are hard-coded for now, but we have fix-me's in there to correct that. The protocol is text lines. I want to move to a binary protocol for efficiency. I'll do that some other day. I just want to check this in. So key codes. Oh, right. So this should probably be its own check-in, right? Just combine them. Why not? Git commit. So get right side to participate in key reports. So, add prefix to all text lines sent across UART in order to distinguish, can't spell distinguish, between log messages and key reports. Combine local key report with peer key report. And like use different scan codes. Left versus right. All right. So I still make lots of errors on this corn keyboard that I'm trying to just use all the time to get familiar with it, because I'm also using a Comac layout now rather than QWERTY, and it's hard because I've been using QWERTY for like forever, for like 20, 30 years. You think that there will be a Rust QMK eventually? It'll be written by me. I don't know about QMK being rewritten in Rust. I think everyone who uses QMK is pretty happy with it being written in C. It's fine. There are other Rust crates out there that replicate QMK, like was a Kiberon is a Rust crate that kind of has a lot of elements similar to QMK, and I'm making my own. I really don't know. Can't believe I didn't make this with my own x86 processor. Well, I did start out trying to use a Raspberry Pi Zero, and that was completely my stuff in bare metal, and that was a nightmare. QMK made in Rust right here. I don't know. Maybe if I refine this enough and add stuff to it, and then eventually, I don't know. I'll just be happy that I wrote something, or used something that I wrote myself. Okay, I'm gonna make sure I push that. Yeah, so I'm gonna end it here, and I'm not sure what I'll work on next time. Maybe just refinement. I want to use a nice binary protocol like this Fix Me says. What else do I want to do? I'm not sure. I'll have to think about it between streams, but I need to start thinking about the final product and how much of that I can stream. But yeah, I hope you enjoyed today. Probably if I could figure out what I'm going to do next in time for tomorrow, then I'll stream tomorrow. How about that? If I can't figure it out, then it might be a few days. Gosh, there's no one I know that I can raid right now. I've been hoping that like my Australian friend who streams game dev would stream and I could raid him, but he hasn't been on when I'm finishing my stream lately, and I'm not sure why. Anyway, I will just see you guys later, okay? Take care. Until next time. Bye.